In this video, we're going to look at how to do a full analysis of a quadratic relationship. So we've learned how to recognize quadratic relationships at this point when they're in vertex form. In vertex form, it takes the following form, where we have three constants, and that is A, K, and H. And what we've learned at this point is that we ask ourselves if we substitute in a value for x, will we perform the operation associated with each of these letters before the squared or after? If it happens before we apply the square, this is said to change the x colocation. So since we're minusing k, this is called a horizontal shift. If it's applied after the parent operation, which in this case is squared, it's going to affect the vertical position. So multiplying A means we have a vertical stretch, and adding H means we have a vertical shift. Remembering that if A is less than 0, we have a reflection as well. So we look here for our reflection. So we start off by looking and we identify the parent function, which we often notate as p of x. Now again, at this stage our parent function is always going to be x squared, but the reason why it's so important to identify this parent function is that in later courses you graph a variety of functions using these same principles, and the first step is to pick out the parent function. Next we want to pick out the vertex, and we know the vertex can be read directly from vertex form. That's why it's called vertex form. So we see that this function has a shift 1 to the left, and it has a shift down 3. So our vertex is going to be at -1, -3. Then we ask ourselves if there's a maximum or a minimum. So before we answer C, let's do D, direction of opening. Since there's no reflection associated with this function, we know that this opens up. And since it opens up, we know we have a minimum value, and that minimum value is going to occur at the vertex. So the minimum value occurs at y equals -3. It's important you say y equals something, because that is the value that we're interested in. Next is the axis of symmetry. The axis of symmetry is a line that can be drawn through this shape such that it has a symmetrical, it's a symmetrical reflection across it. And the axis of symmetry is always x equals something. In this case, it will be x equals -1. Note here that we see the minimum or maximum value is always going to match up with the y value of the vertex, and the axis of symmetry is always going to match up with the x value of the vertex. And we'll see why that is in a second when we draw a sketch. Next, we want to calculate the y-intercept. The y-intercept, remember, means when x equals 0. So to solve for the y-intercept, we simply evaluate this function f at 0. So I'm going to do that now. So we have 6 times 1 minus 3, which gives me +3. Now, the x-intercepts occur when y equals 0. And the temptation at this point might be to go and try and work through that. But what we recommended here is after you kind of pulled out this initial analysis information, what we're going to do is we're going to make a quick sketch. And that quick sketch is just going to include a couple important points. So in our case, it's going to include the points. Let's just slide over a little bit here. That's a little better. In our case, it's going to include a couple points. And that is, it's going to include the vertex, and that's really the big one. We're going to make sure we approximate where the y-intercept is, and that's going to help us kind of estimate other values later on. So again, with a quick sketch, there's no need for any values on here. You're just going to go, I'm going over 1, down 3, and this is my vertex. So the next thing I do is I now say, okay, well that's over 1 down 3 approximately, And I'm actually going to write that right in. It's important with a quick sketch that you actually write these values in. Next thing I'll do is I'll go and I will dot in the axis of symmetry. I know the axis of symmetry is going to cut right through that vertex, so I'm just going to take my pen and I'm just going to kind of do this. There's my axis of symmetry. Next I'm going to include my y-intercept. It's approximately there. And really, I'm just going to draw a little shape. I know it opens up, so that looks good. And then it's going to be symmetrical on this side, so again, it's really just a rough approximation. And I can use this to confirm all sorts of points. I said this opens up, and I can see that this obviously opens up. I said there's a minimum at y equals -3, which we can see here. So what happens now is that I see that this function crosses the x-axis in 2 locations. So I see that there will in fact be x-intercepts. And in the next video we'll go through and calculate those mathematically.